So this video is just a little bit of practice on similarity. So this question says that triangle ABC is similar to triangle DEF. So what exactly does that mean to say that it's similar? Well, it means that corresponding pairs of sides are in the same ratio. So for example, 8 divided by 3 gives you the same as x divided by 4. Or we could look at that another way and say that 8 divided by x gives you the same as 3 divided by 4. Or indeed the other way round, that x divided by 8 gives you the same as 4 divided by 3. So we can use that property to figure out what x is, given that these triangles are similar. So I'm going to start by writing that x divided by, let's say, the 8, x divided by 8. So two corresponding pairs in the big and small similar triangles is equal to 4 divided by 3. And then I can just manipulate the algebra of that to find out what x is. So I can multiply both sides by 3 to get rid of the fraction. So 3x over 8 equals 4. So I've just multiplied both sides by 3 to get rid of a fraction. Let's get rid of the other fraction and multiply both sides by 8. So we get a whole 3x equals 32. And then finally, to find out what x is, we can divide everything by 3 to get x equals 32 over 3, which is the same as 10 2/3. So as it happens, I got that by starting with x over 8 equals 4 over 3. But I could equally have started with x over 4 equals 8 over 3, and I would have got to the same answer in the end. I could also have started with 4 divided by x equals 3 divided by 8. But then I would have had the x at the bottom of the fraction, and then it might have been a bit messier. Okay, so that was a fairly straightforward example, but now a harder example where you've got the x there, but it's kind of tied up as part of a bigger side. But the same principle applies of corresponding sides being in the same ratio. We just need to think of this as being a small triangle and a big triangle, but they're both similar. Now it's kind of obvious that they're both similar because they share an angle there, and although I've not put it in the diagram, the intention was that those are both 90-degree angles, and then I should have put little parallel markers on here showing that those sides are parallel. So given that information, which I should have included, you've kind of got two similar triangles, but one's slotted inside the other. But the same principle applies. So 9 divided by 6, so the 9 in the big triangle divided by the 6 in the little triangle, is the same as the, now we've got x plus 4 there, x plus 4 in the big triangle divided by the 4 in the little triangle. 9 over 6 equals x plus 4 over 4. And then we can go through the whole thing again of manipulating the algebra to figure out what x is. So I'm going to multiply both sides by 4 to get rid of that fraction on the right. So I've got to multiply the other side by 4 as well. So that will give me 9 times 4 is 36. 36 over 6. Then I'm going to multiply both sides by 6 to get rid of the other fraction. So 36 equals not x but 6x, and not 4 but 24. So 36 equals 6x plus 24. Take away the 24 from both sides to get the 6x on its own. So 12 is equal to 6x. Divide everything by 6, x equals 2. So x equals 2 in this case, and that kind of makes sense in the context of the problem. Okay, here's another one very similar to that. Similar, not perhaps the best choice of words actually, but here's another one of the same kind of type. So we've got 8 in a big triangle. Oh, by the way, I should have said that these two are parallel, and then those two are 90 degrees. So it's obvious that we've got two similar triangles there, a little one inside a big one. So 8 divided by 5, the big triangle divided by the little triangle on the right hand side equals x plus 3 in the big triangle divided by x in the little triangle. So we've got x's all over the place here, but it will work out in the end. So I'm going to multiply everything by 5 to get rid of that fraction on the left. So multiply by 5 and I just get 8 there. But then I've got to multiply everything in this fraction by 5 as well. So 5 times x plus 3 over x. Remembering that when you multiply by a fraction by a number, you're just multiplying on the top, of course. Okay, I've got another fraction that I want to get rid of, so I'm going to multiply everything by x both sides to get rid of that fraction. So instead of 8 on the left, I'll have 8x. So I've got 8x equals 5 brackets x plus 3. I'll just multiply those brackets out to get 8x equals 5x plus 15. I've got x's on both sides, so I'm going to take away as much x as I can from both sides. I'm going to take away 5x from both sides to get 3x. 3x equals 15, and divide everything by 3 to get x equals 5. So the answer to this is that x equals 5. So actually, as it's turned out, so that's 5 there, that's 3 there, and that's 8 there. So they're actually both 5 and 5, 8 and 8. It doesn't look like it from the diagram, but of course in exams, diagrams are never really drawn accurately.